Ashish, you are on mute.
Yeah, early morning, isn't it?
Saturday early.
Thank you. Thank you. Good morning, everyone. Let me start again. And thanks, Prasad, for reminding me. I was on mute
No
and I was
problem.
speaking. Yeah, little introspection I was doing, isn't it? So thank you to have you all here. And that's a good week to start again. I count my week backward because whatever I finish by Friday, that is one week. And then I plan for next week. So I always consider a Saturday as like starting for next week for me so that I could plan out things and use first 2 days of the week for a little bit of entertainment and a little bit of learning and sharing. So thank you all for being here. And we will quickly get started and we'll discuss lots of interesting stuff. So today we have Prasad with us. We have Michelle with us. Hi Michelle. Hi Prasad. I'll add you to stream in case you want to say hello. And
Hello,
then
everyone.
we will keep moving forward. Michelle is
Good
here also.
morning, good afternoon, good evening, good night for few people. Thank
Good
you for
morning,
joining.
everyone.
Yeah, good. So keep your questions coming. We would be happy to answer as many questions as we can. We'll discuss about networking topic. We will discuss about databases, and you are in capable hand of Michelle and Prashad. They would answer as many questions as you can, as you can ask, right? So thank you, Michelle. Thank you, Prasad, and I'll add you again into the stream. Let's get started here. Okay. So based on the recommendation and suggestions we had have done that we have changed the sequence of the things. So what we would be doing now, we would be talking about networking track first, which will be today about peer to peer and other stuff. And then it would be Prasad who would be taking care of the on lab. So we will talk about RDS. I would explain about RDS and relational databases, and then Prasad would go forward and will explain other stuff associated with that. So should be enjoyable session. Enjoy everyone and learn new things. We share resources at least a day before, and hopefully everyone is getting those resources. So leverage those resources. And if you have any other suggestions, like hey Ashish, we found this particular link or a workshop very useful, send it to us and we would be also happy to add that so that everyone gets benefited. Knowledge always gain, you gain more knowledge by sharing stuff, so feel free to do that and we should be utilizing buzz every now and again. I'm not sure anyone else having audio issue. Prasad, do you have any audio issue? Sorry, I removed you. I was adding you. Yeah, do you hear
I
any
do,
house?
yes, I do hear in between there is a, I thought it is mine headset
Okay,
issue, but seems like it's your at your
yeah,
end.
it could be mine because I had to restart set. So give me a minute. I'll try to start it again and let's hope that it would go away. Just give me a minute.
Yeah, no problem at all. So while Ashish is fixing, so tell me, like in the chat, how is your overall, AWS learning journey is going on? Um, are you facing any specific, like issues? So Ashish, seems like you are back.
Yeah, I'm back. Is it better or is it same?
Similar, I would say. I did hear that. Keep talking.
Okay. Yeah, means that's not a good thing. Same issue.
Yeah, same
Uh,
similar issue.
Not sure. I have one more trick to try. So let Prasad talk to you for a minute. I'll go off camera and try the trick and be back with you. Give me a minute.
So yeah, what I was asking was that how are you guys progressing on your AWS learning journey? Is there anything else apart from what we are doing, having this networking track, technical track, and hands-on track that we can do to help you, or anything that we can do better? So let me look at the chat. More than $120 for keeping a VPC. So there should be something more to it. Just keeping a VPC. If you are spending more than $120, then that's too much, frankly. Let me remove Ashish's screen from. Yeah. Okay. Please shed some light on Redshift. Okay, we can share some resources on Redshift. It's a data warehouse. And there are ways to migrate your existing data warehouse onto Redshift, and then there are a lot of ways to use Redshift. And one thing that I really like is zero ETL that is released for Redshift. Like you can have your data on Aurora, and with no extra pipeline you can move your data to uh, Redshift, and then you can run your analytics on that. Ashish, I see you are back, but you're on mute in case if you're speaking.
Give me a
uh,
minute.
th-
Is it okay?
yeah, I do not hear that now.
Is it everyone? I had to reshuffle some USB ports. Better? Yeah, good, good. Thank
Yes.
you. Yeah, so
Ashish,
audio is
couple of things.
important part of anything you do.
Yes, exactly. There are a couple of questions. I'd like to quickly answer them, and then I'll
Go
hand it
ahead,
over
go
to
ahead,
you.
go ahead, please.
What course content go beyond the SA associate? Will the course content go beyond the SA associate level? So if you're looking for networking track, yes, definitely it goes beyond that, because I is covering that into a bit deep. For other track, it is in this particular session, it is a bit basic. But if you look at the previous batch, it was a bit higher. So we try and keep it, based on the average audience. Any suggestions on deep dive on AWS migrations? And yes, we do have few workshops which we will share, Pavan. And then, yes, I think couple of days back, me and Ashish were discussing about, because there has been a lot of demand about migrations. So probably the next batch, the specialist track might be on AWS migrations. That's what we are thinking about. But yeah, in this session, we can share a few, uh, resources on AWS migrations. We do have a lot of good resources on that. Samuel, I'm a data engineer by profession. I'm also planning to attend AWS Analytics certification. Is there any guide for certification? If you can help, Samuel, just reach out to me directly, and I'll be able to help you with a few of the certification guides. Cool.
Good.
Uh,
All right.
all right,
Right.
Ashish, back
So
to you.
thank
I'm going
you.
to
Thanks,
remove
Prasad.
myself.
And sorry, everyone. Things technology always fail, isn't it? So Werner Vogel is right. Just B, you should have always have plan B. There should always be something which could fail and then it would fail. All right, so let me just utilize the time at the most and let me share the screen and we will then talk about the networking track and then we will go about technical track. So maybe a session on container would be nice, an explanation session about SQS. Uh, uh, Coffee Brown, we had a container session in the previous batch, so check for that. Kubernetes, I plan to include it, but again, we have limited time, and sometimes Kubernetes is something beyond for people's comprehension in initial stage, and that's why we have not included. But yeah, keep these suggestions coming. This also gives that food for thought so that we can understand things and can give you better example and give you more technical skills, which will be really useful on a day-to-day stuff. So we'll quickly get started here. All right. So we will talk about VPC peering, the very basic stuff, and then we will talk about transit gateway. So question comes, why somebody would have different VPC? That is first question. We always need to understand why of a technology, not how to implement and what it is. But question comes, why a business or someone would actually be utilizing a VPC peering? What is the need to create multiple VPC? What is the benefit of doing that? Anyone? Why we would create multiple VPC? why somebody would have multiple VPCs created. What is the benefit of using that type of multi architecture? Why I would manage multiple of them? To share resources, that is one of them. Exactly, that is true. What else? Let these questions answers coming up, and don't be afraid to say I don't know. That is still okay. At least you are participating. So even if you don't know, but then I don't know, nobody's judging you. Separate network. Good practice to have environmental voice segregation. Multi-region, yes, that is another region. That's true. To have resources in different region, true. Not to travel through internet. In a way, yes. In a way, yes. But there are other ways also of not to travel to internet. Segregation of environment like prod. So yes, I agree that most of the time we may want to have a segregation, like it is mentioned here by Shiva DevOps, that segregation to have resources in different region. I agree that is also another one. Then we have Raghavendra showing up network segmentation. VPC can be used to segment your network into smaller one, manageable part that can also help to simplify network management and reduce the risk of network consumption. That is a good one. Yeah, thank you. So yeah, these are all the things like segregation we are utilizing, multi-region if we want to go, we would utilize VPC peering. So sometime it may also happen, like I have not seen that answer here, accounts. There may be different accounts altogether, right? So maybe I am a service provider. I want others to connect to my VPC and access some services from there. And that's why I may want to share my VPC. Not the best practice, but it is still a thought in case you have some specific customers to talk to or a specific resources to share. You could go ahead with that. So account segregation is also one of them. So we will keep on expanding that knowledge. Now, hopefully everyone remembers this picture. We are building this network piece by piece. We talked about basic stuff like network ACL, subnet, internet connectivity, direct access, and now we are focusing on region to region VPC peering. It could be intra-region, it could be within region, doesn't matter. It could be across account, it could be within the same account. So VPC peering is a logical connection we create, and we call it in a interface something called PCX, and then some random number associated with that. So whenever you hear a PCX, that is a peering connection which is being created, and that peering connection would be allowing me to communicate from one VPC to another VPC, leveraging Amazon's global network, not sending traffic to internet, and that's how I would be able to communicate to this. And then if it is a VPC, those resources of security like network ACL security group, they would still apply. They are not going away. They would still be maintaining the security the way I want to configure. So that is on a high level what VPC peering is. Let's go ahead and quickly create a VPC peer between two VPCs, and we'll see how these things will be working. Right. So I'll quickly go into console. It is this service is basically much explained better when I go to console. So I'm going into console, and we would be selecting some VPCs to peer to, and we will then use a better way of sharing these resources through transit gateway. So I'll talk also about that. So if I have to share VPC, I need to have a VPC at least, right? Question to you. Do I need to have a VPC with subnet to create a VPC sharing? If anyone has thought about it, if I have a VPC without any subnet in that, would I be able to create VPC share or not? What do you think? I do not have a subnet in the VPC. Can I still share VPC? Anyone? Answer is no. Okay. Let me explain that. Let me explain that. We will see that in a minute. So, all right. So let's go ahead and create a VPC here. And just for sake of it, so let's call it, wow, this is the name auto generation. Was not aware. This is the new thing, but I am now creating. This is, let's call it my VPC01. That's not very creative name, but yeah, still serves the purpose. And then I would be putting it into 10 series IP address. So 10.0.0/16 is the IP address I'm saying, and I'm not creating anything else beyond it. This is in Oregon region. I created my VPC01. That VPC is ready. And now I'm going ahead and creating maybe another VPC is there. Let me just delete that one because I cannot edit CIDR just once it is created. So that one VPC was also there. Let me just delete it, and we would create my VPC02 in a different manner. Maybe there is a security group associated. So let's right now just type ignore it, and then we will keep moving forward. So we will go ahead and create another VPC here. That is my VPC02, and I am using 172 16.00/16 as a network. Now, why I bought that question of subnet? Because VPC peering is not associated with a subnet. Yes, so yeah, so VPC peering and VPC creation, like Sunandam has a question, is it possible to create a VPC without subnet? Possible is, you can, but will that be useful for a lot of things? Answer is no. It's like having a house and having no walls in that. It is just like a plain hall. So you can still call it a house, it's still a VPC, but not very useful. So still possible, but not something to use for a regular purpose. So I have created VPC now. VPC peering doesn't work on a subnet level. It works on a VPC level, so I could still have these VPCs peered without having anything on a subnet level created. Right. So these VPCs exist, and now my intention is to create a peering connection between them. Very simple logic. I would go ahead and search for my peering connection here somewhere. This is my peering connection, and I would go ahead and say I want to create a peer connection. Okay. So let me call it VPC 0102 peer, right? I would be saying select local VPC to peer with. So it is a two-way process. You have to select local VPC and a remote VPC. Now there is no concept of source and destination here. It's not a one-way traffic, it is a two-way traffic. So they both parties involved in the same manner. They both have to agree to this routing table rule and other stuff, and then only communication would be happening. So I say this is my VPC 01, that's why I want to connect to. It detected its IP address, and see this. I could have connected to my account or another account. In that case, I have to select my account ID, and I have to then provide the VPC ID also of that particular VPC. Right now, I am interested only into my account, and this region, I have these VPCs available. I would be connecting it to my VPC. So it was able to identify the associated subnet with that, and then I can give this particular VPC peer a name, which I have given, and then I could just say create peering. So that's what we are trying to do here. We have just created a VPC peering connection. But consider that this is a physical connection as of now. And then if you look at it, it says pending acceptance. So I initiated a peer, and then someone at the other end of the peer has to accept it. You can't just randomly go and connect to anyone. You have to get their acceptance, then only your communication would be allowed. Now I am in the same account, so that's why I could go ahead and just accept this peering. But in real world, it would be some other account or maybe some other admin who would be actually allowing you, would be accepting the peering connection. So I have my peering connections here. This is my peering connection, as you could see, and it shows into a pending acceptance state. As it is my own account and I am the owner of this, I could go ahead and say accept request. But before that, it is always better to check who is requesting, and then when it was created, I don't want to peer with some unknown VPC. It is big security risk. So I have created here a VPC peering, which is for this PCX connection. This was the requester ID and some more details on that, and I could see from where it happened. It could have been across also, and then we could go ahead and add routing table also already. So we'll talk about routing table in a minute. But I saw this request, and if I'm happy, I would say I want to accept this particular request, and then my acceptation is done now. All right, good. So this peering connection is ready. Now, is it sending traffic? Anyone? If I have this peering connection right now, can I start sending traffic using it? Like if I have a machine here into, so we created this architecture so far. And my question to you is, can machines in 172 send request into 10.0.16? Raghavendra is saying no, no, we need route. Exactly. Yes, so we need to have a route table associated with that. We route table would allow me to send traffic. I call route table as a Google map. So maybe a new city has opened up or a new airport has opened up. I won't be able to reach out till Google Map has entry for that because I don't remember every path. So what we need to do, we need to add routing table entry on this case. So let me go ahead and add a routing table entry. In one VPC, I would add entry for routing table on the other side. So I would point my request from 172.13 to 10.0.16 on to the PCX, and PCX would take care of all the things for me. So that's what I'm trying to do. I would go to my route tables, and I would be selecting a specific route table associated with my VPC, which is my VPC 01. Let's go ahead and check that. I'm adding this into default route table, but you could have added it into other route tables also. Let me quickly check the name of these VPC so it would be easy. I'll note it down on a notepad so that we can refer it again and again. So this is my VPC 01, and then this one is my VPC 02. Just to save time, I have put everything into one single location, but you could have done it on another location. So I am on this VPC 172.16. I have its detail. I know which route table it is associated with this. So this is my route table associated, and I would just go ahead and say, okay, route table, let me add an entry. Currently, it has entry for only local communication, and you can't remove that. What I'm going to do here, I am going to add more route, and this time I'm saying I want to talk to a destination which is 10.0.0.0.16, sorry, 0/16, and that should be forwarded to whom? Anyone? What I should select as a target? Probably you would have guessed that I would select a peering connection. I only have one peer, so it is being displayed here. I have selected that, and now I have clicked on Save Changes. All right, so I have set up this route table entry here. As you could see, this is what I have done. Now my question again. I have a machine here, and I have a machine here. Can they communicate right now? I have peering entry. Can they communicate? We need to add a route from both the region pointing to the subnet of the other region, not the subnet. Pralay, we are not pointing to subnet. We are just pointing to PCX, and PCX would decide how to forward the traffic. Now, the VPC which I created, they do not have IGW at all, no gateway. So they can't communicate because TCP, let's say I go ahead and say ping. So ping is a two-way traffic. My requests need to know a path to go from here to here, and these machines here should have a path to respond back to me, right? So that person who sent request knows how to reach to 10.0.0.16, but the person in 10.0.0.16 doesn't know how to talk back to 172. So what I would need here, I would need a routing table entry also here. Then only this communication would happen. Otherwise, it won't happen. So next thing I have to do is create a peering table connection here into this. So yes, we need a reverse path exactly. The routing table is not smart enough. It has to define both the paths associated. So that was the first route table I have associated, and I would go to my VPC 02 and sorry VPC 01, and in its route table I would add entry for other location. So let's go ahead. This is 10.0.0.16. I would go to its route table here, and I would now add entries for my routing communication, and that will be a simple entry by editing a route, and this time I would try to talk to 172.16.00/16, right? And that will be what my target would be. My target would be again a peering connection which we have just selected, and now I have taken care of peering, right? So what I did here, I have made changes into the default route table. Is PCX a VPC endpoint? Answer for that is no. No, PCX is not an endpoint. It has a some routing table entry, so it works little differently. It behaves like an endpoint, but it is not, because endpoint, again, this is a little longer discussion here, Francis. So it is like endpoint are two. One is gateway, which requires route table entry, so it sounds similar to that, and another one is your interface. So it is not interface at all, because interface requires you to have a subnet, and in that subnet it would create a network interface. So that is not at all something which we have here. Or can you have default route to that VPC? Default route, not directly. Let me show that. That is a different way of doing it, but the question has come, as it is coming from Hari Krishna, that can you have a default route to that VPC? Not directly, but there is a way of doing it. So see this. I am saying my 10.0.0.16 is local, but here I could have used these. So I could forward my local request to an instance which I am acting as a proxy, or a network interface which could be leading me to somewhere else, or to a gateway load balancer, or just I am keeping it local. So there are ways of doing it. We will talk about that when we discuss about a network firewall. So you should be able to create this kind of logic. Plus you should be able to also have transit gateway coming into picture. So we can create those stuff, but not right now. That will be a little too much for today. All right. So hope this thing is clear. And we have now peering connections set up, and we should be able to send our traffic across both of them. So they're very simple, not a complicated thing. And hopefully you have a better idea on what we are getting. Is peering is not two-way. It is two-way, Babita. So you need to still set a route. So see, peering is two-way because I had to initiate peering and somebody has to accept the peering. So yes, it was a two-way communication, but the path is physically there. But if I'm not making my route table aware, then it path is of no use to me at all. So yes, we have between VPC, and we will need to communicate to them through routing table. So routing table would still always be required in that case. So VPC peering is established into one-to-one fashion. I would have one VPC connect to another VPC. So this is my A, this is my B, and I have to establish a peering connection. This is how a peering connection looks like. So that's what VPC peering is actually allowing me to do, right? Next thing, you could set up cross region, cross account peering, no problem at all. That completely works. You should be able to provide those kind of security. And then two-step process, request peering connection and accept peering connection. We just saw that. So that is possible. We could have utilized that. And route table entries direct the traffic. All the mechanism of forwarding is done by route tables. Plus peering connection use private IP addresses. Traffic always stays on AWS global backbone. So we would be automatically identifying the IP address range, which is private, and will forward traffic always going through that. So that's how you would utilize that thing, right? Now, okay, last topic question here. There is no charge to create VPC peering connection, but there is a charge for data transfer across peering connection. So when I create a peering connection, no problem at all. But when I'm trying to have a traffic sent over it, I would be paying the data transfer charges on that. So just be aware about that particular thing, right? Uh, for path for each of this subnet. I won't say subnet Hari Krishna here because I may not want to talk to one subnet. I may put a path of the whole VPC IP address range. So if you remember this route which I have created here, I'm not pointing to a subnet here. I am pointing to the whole VPC range. So anything now here, if this VPC has subnet 1 or 2 or 3, whoever is in this range will be able to contact. Still your security group comes into picture, still your network ACL comes into picture. So you should still be able to access those things. Shouldn't be a problem at all. So I hope this thing is clear and you have a better idea on that. What will happen if both VPCs are in sharing same subnet? Good question. We won't be able to communicate across them. So one requirement for a VPC peer is that to not to have overlapping IP address. So overlapping IP addresses will not work. They should not have overlapping IP address, because if you are using the same IP address, this one is using same IP address. Now how route table will differentiate which traffic to send to whom? So this will not work in this particular case, but there is a workaround for that particular thing, Hari Prasad. That is called a transit gateway. And through transit gateway, even if you could create a solution where your VPCs, even with the same subnet IDs, sorry, same IP address range, would be able to communicate, but it is a solution, not a default setting. So you have to set up that solution by creating a transit gateway and then configuring route table and configuring NAT gateway associated, but technically possible. Official answer, if you get a question in exam, two VPCs with the same IP address, I would say it is not possible. We can't pair those two VPCs, right? So there would be some checks performed before we end. Can we create routing without peering connection acceptance? I haven't tried that, Hamel. So I'm not 100% sure. If I have not accepted that, can I create it? Let's go ahead and quickly check it. Nothing wrong in just verifying something. So let me try to create a peering connection first, and then we'll see if we can connect to it. So I am into my peering connection. Let me create a peering connection here. Let's call it test peer, and this time I want to connect from, let's say, my VPC01, and I want to connect into another region. Let's select if we have something into Northern Virginia, and if I have something in Northern Virginia, I should be able to get connection to that also. So let's go ahead and quickly try that. If without acceptance also, can I create peering connection or not. So I would still be able to probably create, but it won't accept any traffic because it is not into acceptance phase. But let's quickly check that. Good question. I haven't thought about that scenario, but let's try that. Okay, so let me go to Northern Virginia. Probably I have some various range of VPCs created there. I would try to connect to any one of them. Just I need to get the VPC ID associated. So I have 5 VPCs here. By default, you can have up to 5 VPC. If you're going beyond it, it won't allow you. So just be aware about that also. So let's say I want to connect to this VPC-C, which is having this particular IP address 10.3.0.0.16, and I am trying to connect to Northern Virginia VPC, and I said create a peering connection. So I have created a peering connection. It is initializing request to done. That is all good. Peer request has been requested, but it is not into the acceptance state. And let me go ahead and now pending acceptance test peer, and I would try to create a route table entry for this. So let me go ahead to VPC 01 and try to create a route table here entry, sorry, route table entry here, and we'll see if we can create those specific settings or not. So screen area is very small. I have this route table. These are my routes. I would go ahead and say edit route, add route to 10.3.0.0/16, and let's see if we can get a peering connection. Yeah, I can still have route table entry added. I can still add it, but obviously it won't be actually sending any traffic because it is not into active state. See this? So it will still be physically route present, but it would be into black hole state. Black hole is like, as the name in the physics is black hole, which is not allowing anything to be coming out of it. It sucks everything. Same thing. So you would be able to send packet, but you will not be accepting any request response coming from that. So technically you can create entry, but it would be pointing to black hole. Right. Good, nice. Let's move forward then. Now, so that is clear. That is not a complicated topic. Probably most of you know about it. And let's now talk about transit gateway. So let's go ahead and talk about what is transit gateway and how it works. And I can't explain things without analogy. So let me go ahead and explain it things through an analogy so you would understand it better. Right. Hopefully everyone can see the drawing I'm going to make. Right. So let's go ahead and talk about it. Now, let's say I am living into UK, right? In UK, there are different cities. There is London, there is Leeds, there is Manchester, there is Cardiff, and then other cities, right? And let's say I have to fly from these cities to somewhere in India, right? In India, let's say cities are New Delhi, and then we have Mumbai, then we have Bangalore, and yeah, people will hate me for not calling it Bangalore, and then we have Chennai. And there would be tier two cities, like I belong to a city called Indore. So that is a city. Now, if I have to go from, let's say, Leeds to Indore, that is not a direct flight. What I have to do, I have to come from Leeds to London Heathrow. Even Manchester may not have direct flight, even Cardiff may not have direct flight, because that would be very complicated for airline to maintain one-to-one connectivity to every city in the world. That is kind of impossible, and they may not have that much of traffic coming into it. So what these airline companies do, they operate into a hub and spoke design. For British Airways, London Heathrow is the hub. All the people or passenger from wherever they are, even from different countries, they would be flushed, they would be brought into London Heathrow, and from there you would be able to get into the next location of it. And again, if London Heathrow is trying to fly, they won't be directly flying to Indore, maybe they would be flying to the again a hub in that country like Mumbai or New Delhi, and then I have to take another flight to reach to my place. You get the point? So this is a hub and spoke design. And if you look at any airline, they all have their hub, right? British Airways, the hub is London Heathrow. Air India, Mumbai and Delhi are a hub. Emirates, there is a hub into Dubai for that. If you're talking about Lufthansa, their hub is into Berlin. So every airline has their hub. They get all the passengers into hub, and from that hub they start the flight, right? So that's how your actual logic works. Why? Because it is efficient. I don't want to keep on creating that many flights, which will be really, really complicated to maintain, operate, and it will not be economically viable. So that is the concept of transit gateway also. Nothing complicated, exact same concept. Let me explain that thing now. So if I have a VPC here, A, B, C, D, E, they have to all talk to each other. A, B, C, D, E. One option for me is I could go ahead and create a peering from here and here, then another peering from here to here, right? And then one more peering connection between them, another peering connection between them, and then these peering connections. You could clearly see how many peering connections I have to keep on maintaining. And this is only 5. If I add one more VPC now, I have to again reestablish all these peers. So this is not at all a scalable design. So what we can do in this particular case? In this particular case, we could take help of transit gateway. So what we will do, we will deploy a central piece into this puzzle, which is my hub, and that hub would allow me to communicate to various aspects of my communication. So this is my transit gateway, or we call it TGW. And through this TGW, we could create a communication channel, like it is allowing A to communicate, B, C, D, all of these will communicate to transit gateway. That's what we are trying to do here. So transit gateway is a hub for your request, and all the VPC who are connecting to it, it is my spoke. I hope this thing is clear. Now, one thing to be aware, this transit gateway is a regional entity. It exists into a region of your choice. Like I said, in UK, the regional hub for British Airways is London Heathrow. Same thing here. Transit gateway exists within a specific region, and then you would keep on adding more VPCs to it. Now, if let's say I'm going back to my airline analogy, if it is London Heathrow, if it is considered, now people will not always come to Heathrow by flight, right? Some cities which are nearby, which are not having that many of, let's say you are into Cambridge or you are into Oxford or or other cities, you may just take a train and come to it. Same way, this is not only for connecting your VPCs. What you could also do, if you have other type of connections also. What I mean by other type of connection, if you have a direct connect connection, or if you have a VPN connection, they can also be coming and connecting to this particular transit gateway. And now you could see this has become like a central place where everyone is coming and everyone is able to communicate using it. So that's what we mean by a transit gateway. We can keep on adding more and more resources, and we can have up to 5,000 VPCs connected, and that would ensure that we are able to provide as much as the traffic coming from central place. I hope everyone is following along now. So this was the right picture till few years back. Now AWS thought that okay, so London Heathrow has to be connected to another hub. Let's say Amsterdam Schiphol Airport is another hub into Europe where a lot of traffic happens. Or if I'm talking about US, maybe JFK is the another airport where a lot of traffic happens. So JFK is happening, or let's talk about Delhi. So that's if I'm talking about New Delhi here. New Delhi is again having lot of traffic coming from different cities in the India, and the same concept of having people arriving here by bus or train or something also exists, but this one is in a different region altogether. So what we support now, we now support transit gateway peering also. You could create a peering connection between them also. So this is called my transit gateway peering. So this peering will allow me to communicate across transit gateways also, and I can now create a flight. Let's say I'm coming from A, I would come to transit gateway, and then I will be going to New Delhi, and from New Delhi I would be going to somewhere else. So that is how I would be able to go ahead and utilize all the component and create a whole scale network so that all type of communication can happen and we can communicate across different type of network. I hope everyone is following along and for understanding the basic look idea. Any questions so far? Anyone which is not clear? Anything which is not clear, let me know. So that is your transit gateway, right? And that transit gateway would allow you to perform all the communication like the way you want. Now, in default condition, when I create a transit gateway, I'm talking about default. In default condition, everyone is allowed to talk to everyone. That is a default condition. But obviously you do not want it. You may want to keep a specific stuff available only to specific location or a specific resources. So let's say this is my dev VPC. I want only to talk to QA, and this is my prod VPC. I may want it to talk to only pre-prod. So what transit gateway allows you, transit gateway allows you to create multiple routing table and create association. So this routing table would have entry for very specific route or very specific traffic. So only those specific traffic will be allowed or denied. That is how you could control who can talk to whom. So that is what a transit gateway is actually doing. And this type of design can help you in some other concept. So let me utilize another option. Let's see what we can do. All right, so I'll talk about that. Question from Kurt is about VPC peering is regional, transit gateways cross regional. No answer is wrong on that call. So peering can be across region, within region. Transit gateway itself, when created, is within region, nothing beyond it. Transit gateway won't go beyond a region. If you want, you have to create another transit gateway in another region and then create something called transit gateway peering. So transit gateway is a regional entity. Transit gateway peering, it can now, I believe, happen within the region also. I'm not 100% sure. Anyone, Michelle, Prasad, if you could check that if a transit gateway peering is, I believe, is now supported within the region also, but I may be wrong. I may be dreaming. So just check that and let me know if that is possibility. Let others know if transit gateway peering can happen within the uh, region. I doubt it, but let's check. Okay, so this is my transit gateway peering. I hope analogy is clear and you have a idea on this. So that is what we are doing. We are getting everyone from Edinburgh, Newcastle, Leeds to Heathrow, and then we are bringing them to Delhi, and then other cities would be connecting to that. So we would utilize that. So that's what can happen. Question from Pawan. In this hub and spoke model, do we still need to have routing table entry for A and B? So routing table for A will have entry for VP and not on those locations. So Pawan, what it will be happening, I'll explain that thing to you now. That was my next point I wanted to discuss about. So what we would do in this particular case is, so let's say this is my three VPCs. And this is a direct connect and this is a VPN. So this is my direct connect. This is my VPN connection. This is my VPC A, VPC B, and VPC C. And this is my transit gateway here. What we would do, we would say transit gateway should become the next point of contact for everything. Now, this is a good design. With transit gateway, what I could do, I could also have connected something called a shared VPC. This is a good design which you could follow in your environment. Now, on the shared VPC, I have done all these connectivity, like my IGW is connected to this shared VPC, not directly to any other VPC. So these VPC A, B, C, they do not have IGW. What they have always sending their traffic. So I would add their training routing table entry, and let's say this is in 10 series. So it will have an entry which will be in the routing table 10.0.0.0/16, and that would be pointing to local. And then I would have an entry 0.0.0.0/0 that should go to transit gateway. So what is happening here? Anything which is not matching to the local, that will be going to TGW, and this similar entry of everyone forwarding traffic to TGW would be there. So TGW would refer all traffic, it will get all the things, and then we should be able to have a component connected which will allow traffic to be forwarded. So I would say, okay, B, you want to go to internet, no problem. You just send traffic to transit gateway and let it decide how to forward traffic further. So that transit gateway would allow traffic to communicate, and then you can create routing table entries in a way that you could say, hey, I want A and B to communicate, no problem at all on that. So A would send traffic to TGW, then it will forward to B, so they would communicate, but I don't want A and direct connect to have any communication at all. So direct connect is also coming to transit gateway, but we could create again here a black hole route which will block traffic to go from A to DX. So that's how we would be creating routing table entries and communication. So idea I'm trying to convey here is that most of the time you would have a shared VPC with transit gateway, and all your common services, let's say Active Directory or your Exchange servers or your antivirus services, they would all be running into shared VPC. Even IGW is connected here. So all the traffic which has to go out, they would all be forwarded by transit gateway here. Everyone communicates, and then all filtering and all shared services are in one place, and then I could utilize my IGW to get connected. So I hope this thing is clear and you have a better idea on how all these things work together. So that is called my transit gateway. Okay, all right, good. Another example I take for transit gateway is transit flight, right? So let's say if you have to go from, let's say you are in Bali in Indonesia. I have taken that flight, and that's why I can relate it. And I had to go to New York. There was obviously no flight from Bali to New York. What I had to do at that time, I had to go from Bali to Singapore. From Singapore, I was able to get a flight to Amsterdam, and then from Amsterdam, I was able to get a flight to New York. The good idea is we are utilizing Amsterdam or Singapore as a transit point. And from transit point like Singapore, you would have flight to different parts of the world, not just Amsterdam. And same way, Amsterdam would also have flight to different parts. So transit gateway is basically allowing you to not talk only to different transit gateway, but it can also allow you to communicate to anything. So once you are here, I came to Singapore, now I want to take a flight for Delhi, or I want to take a flight to Dubai, or I want to go to Kuala Lumpur, I could just go ahead from there. So that would be much easier for me. So transit gateway will become your hub and all your traffic would be forwarded from there. Now, we do not have time, so I can't explain more details, but I'll talk a little bit more on transit gateway. So this is what a design of transit gateway would look like, region one, and then we would be utilizing it. Question from Pawan, when a VPC becomes shared, when you add its entry into routing table. So it is no option which says right click and share a VPC. Shared VPC is a concept. So it is still same VPC, but shared in the sense that I'm running some services there which we want to share, and for that we created routing table. Right. So that is your shared VPC. Like in your house, there would be one room which is common for everyone, right? For me, my room is there. For my son, my there is he has his room, and then we have a living room which is common for both of us. So that is my shared VPC, but we still have our own VPCs, right? So that's what we can do. And transit gateway would have transit gateway peering also if the need be. So we will go ahead and quickly show how the transit gateway looks like. There are three components for transit gateway. First is to create the transit gateway itself. So I would need to create a transit gateway. That will be same way like you create a VPC. So I'm in Oregon region and I say I want to create a TGW. I would say TGW01 and see the setting. Do you want DNS support? Do you want ECMP, which is equal cost multipathing? Default route table. If I select this, anyone who I connect to should be able to talk to each other, and I can have default route propagation. So I'm not making any changes and I'm just saying, let me create a transit gateway. Once this transit gateway is ready, it takes little time to get created because this is doing a lot of stuff behind the scene. Next thing would be to create something called a transit gateway attachment. So once my transit gateway is ready, I would then say I want to have a transit gateway attachment who should be able to talk to my transit gateway. So I say this should be my VPC01 talking to transit gateway, and I would be waiting for the transit gateway to come up. But here you see to whom I can attach. So the attachment allow you that connectivity string, VPC, VPN, peering, and direct connect also. These are all the different options. VPC we already discussed, VPN already we discussed about. Connect is your direct connect, and peering is when you are trying to connect to a transit gateway in other account. It would still be same process. You would initiate a connection and somebody would accept that connection. If it is a VPC peering, then you have to just provide the name of the VPC and we should be able to communicate to it. And now I would be needing subnet, because what transit gateway is doing, transit gateway is creating a network interface in the choice of the subnet you specify. It is requiring a network interface to be present, and all your traffic will be funneled through that network interface. And subnet would be required in this case. I can't connect to it because I do not have any subnet here. But if I'm connecting to, let's say, this, I have a subnet and I should have no problem in connecting to that. So that's why transit gateway communication would require a subnet, because it works with a network interface card. And once this attachment has been created, what I would also need there, I would be needing a routing table entry. So this transit gateway is getting ready. Let me explain one more thing. The last topic here is called my transit gateway route table. My default route table has a similar entry like my standard route table. If I go back to this route table, I could see the routes inside, and you could see what are the routes associated on that. So see, these are my routes here, right? So I could create a static route entry here, and I could go ahead and say, okay, what I want to talk to, active a block hole, which attachment will forward the traffic. So three components are required for transit gateway itself, second is the attachment, and third is the routing table. If you don't want to modify any entry, use default route table. Otherwise, create your own route table. And here, if you want communication between two entities, you could create that and say put it into black hole. So I could do that, and I could say, okay, this is going to be black hole. So anything beyond this will not be allowed to go afterwards at all. This is how your transit gateway would be working. So I hope everyone has a better idea on how this thing works. Again, we have limited time, but yeah, I would be happy to answer any follow-up questions you have. What I have included your first one-page summary book. So just check this for transit gateway. There are some details on that how it works, when to use it, who manages it. So this would be available into the resource section. It is available in the resource section. You can go and grab this one. Okay. Uh, Overcoming IP issues. Yes, I have a link for that, Pawan. I will be happy to forward. Just ping me on LinkedIn. I would be forwarding you. There is a solution created and it is a GitHub repository. I will share with you. So we can do that. Okay. So everyone, thank you. Let's take a 5 minute break and we will then switch gears and then we'll talk about databases. I know I've already consumed extra 5 minutes, but hopefully everyone is enjoying. So in next 5 minutes, we will re-energize and then go to the next topic. So enjoy your break. Talk to you in five. Thank you. Welcome back, everyone. I hope everyone is back. If you are back, type in chat your favorite mobile app. What you spend your most time on your mobile. Anyone? Any specific app which you spend a lot of time on? Obviously, a lot of social media apps would be there, I guess. So, Vuduku, WhatsApp. Yeah, WhatsApp is something which steals a lot of time. I agree on that. What else? I haven't checked that Vuduku, Michelle, so I have to check that. Okay. Then WhatsApp, yeah. And then, yeah, again, WhatsApp, LinkedIn, Pralay, that's good thing. Twitch and LinkedIn, okay. Good. Facebook, Telegram, okay. Telegram is another thing I have never used. LinkedIn, yeah, I use that. Fitness, LinkedIn. Fitness, LinkedIn. I was not aware about that. But yeah, it's good to know and good to know all this perspective when you share all this information. Thank you. These days, Udemy, that is a good investment, isn't it? Right. So yeah, that is a good investment. All right. So we will keep moving forward, and thanks for sharing all these information and themes and outlook. Come on, this is official, isn't it? Keep checking off this thing, Hari. This happens always. Like you have a urge to check email even on the weekend. Sometime we should stop it. So I try to follow, but it is very, very hard to be honest to not be in touch with what is happening in the world. And we are in global team. So like some part in the Middle East today is a working day, sorry, to maybe on the Sunday it would be a working day for them, so that would be like still they would be sending messages and then maybe you will be looking into it. So yeah, that is interesting. Okay, let's keep moving forward. So we will now talk about databases into the cloud, and I'll keep the conversation focused again on basics of the databases, and then we will go into the details of it, how it works. So we have SQL and NoSQL databases. This is a very common thing. A lot of people have a complication in understanding it. So I'll try to cover SQL and NoSQL databases. We sometimes refer them as relational or non-relational. So you decide whatever you want to call it. But the idea is that we want to store data in a different format. Now, let me use some analogies again to explain you the concept associated with that. And probably some of you would relate to me now when I'm sharing this. Let's cook a banana bread, right? Obviously, it's a Sunday coming up tomorrow, and this is my plan. I'm not sure if I follow the same recipe, but idea I am trying to convey here. If I have a recipe book and if I'm trying to bake something as the banana bread, what I would do, I would go to the page number of that banana bread and I would get all the details there. I don't have to keep on looking from page 1 to page 5 and then 5 to 12 or 15 or 17. What I have here in my front of me is a document, and all my information, whatever I need, is there into this document itself, right? So that is what is information presented into one single flat structure, no relationship from this table to that table or from this page to that page. That is my one single page, and this is what we refer in any technical word. This is a document. When we say document, it doesn't mean Microsoft Word document. A document is a place, maybe into a JSON format, we would have our data being stored here, and that is all information about making up the banana bread, right? This is your non-relational database. Everything in one place. You go ahead, get the document, go inside it, and figure out how to find out the information you need. All right. Now let's focus on the second aspect, non-relational. See this ingredient list? Now I don't expect that I have all of these things in my home as of now. So what I have to do in this case, I have to go to a supermarket. And on that supermarket, I would have a shopping cart and I would keep on filling that stuff, whatever I need, into my shopping cart. That is your relational database. You have different tables, table 1, table 2, table 3. Maybe it has drinks, it has fruits, it has cheese, crisp, and that's how you would be bringing multiple records into your shopping cart by writing a SQL query. And the SQL query would go ahead to different table, get the required information whatever you need, and bring it to you as output. So that's what is a relational database, in which there are different tables, and you run query which goes across tables and deliver you the result on that. So I hope this basic information is clear. Then in relational databases, you would have different table. Collectively, they will give you a data. And in your tradition, in your NoSQL database or non-relational, probably there would be one single flat document in which your data would be stored and delivered back to you. So I hope this thing is clear to you and you have understanding on this concept. Let's now go ahead and talk about the not then other technical thing associated on that, right? So yeah, hopefully this makes your life easier, right? So when you will now go to grocery store, you would see it in a different manner and you would be having your cart, which will be your SQL query, and you would keep on adding stuff inside it. So hope you are following along. All right, let's move forward. Now, in a SQL and NoSQL database, SQL databases store data into rows and columns. That is a common way, whereas NoSQL have different ways of storing data, which is your document, wide column graph. What I have explained right now is rows and column. That is your table coming from different places. The data is coming up, and in a document, your data would be stored in this format. Like I have ID1, full name, last name, and year, and all. That's how these things would be working. Right. Now, what I have here, another concept we have written, NoSQL, which is optimized for performance, and SQL is optimized for storage. That is also a key factor on how the data is stored inside these locations. Let's talk about it. This picture I have shared in my previous session also. What is happening here? This is a 5 MB hard drive being moved from IBM capacity, IBM facility. This one is called portable 5 MB hard drive. Is it portable? Yes, it is. If you have 5 men and a one van, then it is portable. So that is how transportation of hard disk used to happen. Point I'm trying to clarify here is that hard disk initially was very, very costly. So any solution which were designed, like relational databases came into picture in 1970s, and that time they wanted to keep storage cost as much as low as possible. But if you look at today, this is a small fingertip like 1 TB storage device you could get, and that is much, much cheaper now. So storage is not very costly now, and that's why our requests are requiring more performance. So in earlier days, storage was very costly, computing was not, and that's why we had designed everything to store our data in a storage efficient fashion. But now with web scale application like Facebook, Amazon, Google, millions of users are accessing it, and we want to ensure that everyone get the same performance provided how much data is there or how much data you want to keep inside. So that will be always there. We want to have say best performance coming up. So compute is our priority and not the storage now, right? So this is other format which no SQL data can store data in. So it can have a key value pair, right? So I'm using username, Ashish, password 1234, city, London, graph. This is another database like social networking. A is friend with B, B is friend with C. Let's recommend C and A to be friend also, or a wide column database or a document. So no SQL, they are storing data in a way which will give them the best performance rather than focusing on the storage space. So that is another difference between SQL and no SQL databases, right? Next one is schema. SQL databases requires you to have a fixed schema. You have to be very thorough with your schema design on very first time, like what keys you want to include, what values you want to have, what would be the table items you want to keep, and that all information would be required when you are using the schema which is fixed. On the other hand, here no SQL, it is a dynamic schema. So I have items here, and you could see one item may have more values inside or attributes inside than the other, and it is completely acceptable, completely flexible that you may utilize different type of things there. So NoSQL allows you to have that kind of flexibility, right? So that is your NoSQL, right? Flexible. Now schema fixed. I take another example here. When you travel to air, so airline would give you a size for your luggage, right? That your luggage cannot go beyond that size. So when you are carrying a cabin luggage, you cannot go beyond that particular cabin size. That is your fixed schema, right? But when I am sending something through a big courier company, then I may send a guitar maybe, right? So that is possible. I could package it into it and send it. So that is my dynamic. They accept different package sizes, but my airline accept a fixed size for my cabin luggage. So that is my fixed schema and dynamic schema, right? Now, how to query these data? In a standard way, We use SQL query like I'm saying select star from music where artist is Elvis, and that's how we are able to get the Elvis information, all the music created by Elvis. On the other hand, here we are saying, okay, I want to talk to a table called music and I want to search there or an expression where the artist name is Elvis. So I would get the similar data available, but the query format will be not SQL, and that's why we sometimes refer it as a no SQL. But this line is becoming blur and blur day by day because now we have databases which are physically no SQL or technically no SQL, but they still allow you to write SQL query. An interpreter in between will translate it into a different format, get your result, and you will feel I have just written a SQL on an SQL database. So that is also there. We could utilize it. Next is scaling. So scaling is vertical in SQL databases. It's a single node, and then I would add bigger node. I would throw more CPU and memory to solve the problem, and I will keep on making that node bigger and bigger. But I would soon hit a limit that how much physically I can put it into one node because there is a limit in terms of physics, how much power I could put to one node, cooling I can provide, physical size or dimension of it. So I would soon hit a limit in terms of vertical scaling, as we see here, whereas your NoSQL databases are using horizontal scaling. So I'm using node 1, I add another node, I node another node, or sometime in some databases this is referred as partitions. So they would keep on adding partitions and keep on adding as much data as you want. So that is called my horizontal scaling. So I hope this thing is clear. Now, another good thing which are about SQL databases that they support transaction. Transaction is basically when you are doing an activity which has multiple phases inside. I call that transaction. So let's say I have to transfer money from my account A to someone's account B. So in that case, that money has to be deducted from my account. It will go to my bank's account. That bank will transfer to the destination bank. So now it will remove from their account, will go to this bank account. This bank will check this account, remove from their account and transfer here. And when this happened, this whole process is a transaction. Right. Now, in this whole process, if any of the phase fails, then your transaction would not be carried out. Like you're buying something on Amazon.com. You bought that product, so your credit card should pass. Amazon should have a delivery location, which is your destination you selected. Amazon should have option to deliver on the time frame you selected. You want next day delivery, but what if your location is not supporting next day delivery? So that transaction won't happen till every phase of the transaction is complete. So that we need here, that is sometimes is referred as ACID transaction. Your transactions are atomic, consistent, isolated, and durable. So we support these transaction on that. No SQL. Again, as I'm saying, that line is becoming blurred day by day. Some databases they are no SQL, but they still support transaction. So support of this transaction varies. Or just to create a similar terminology in terms of ACID, they call it base. So these NoSQL databases support concept of basic availability. They have data into soft state and they may have eventual consistency. So that is called acid and base, the chemistry thing. Acid is opposite of base, base is opposite of acid. Similar stuff we are using here into this particular language. So I hope this differentiation is clear. And when we will talk about DynamoDB, we will talk more on these type of eventual consistency or soft state and basic availability. All right. So I hope this thing is clear. And now we would start focusing on Amazon solution, which allow to use. NoSQL mostly follow CAP. Yeah, I agree on that, Samuel. So CAP is a theorem which you could check on internet, and NoSQL would be mostly following the CAP theorem. Let's talk about Amazon's RDS service. Let's see why we need a service like that, how we would be utilizing Amazon RDS, relational database service. Right. Let's say I want to run a database and that database I want to run on my on-prem environment. All right. So I on-prem, I have to take care of rack space. I have to have physical space to host my server. I would have cooling and ventilation done. I would deploy a physical server, have operating system installed, patch it, database software installed, database patching done, then backups configured, high availability configured, and scaling configured. I am doing all these things. So that is a lot of stuff which I have to do. What if I want to use cloud? One option for me is I could go ahead and say I would take a EC2 machine so that all these things of operating system installation, physical space, its cooling and ventilation, rack space is all done by AWS. And once I have this EC2 machine, On top of it, I would then install my own database, but in this case, I am still worried about patching of operating system, high availability, scaling, and all. So what you see here, these are your unmanaged databases. You manage them, unmanaged. Amazon RDS is a managed database service. Amazon RDS says, all right, we will help you in achieving whatever you need. And these activity where you had to spend a lot of time like scaling, high availability, backup, patching, they will all become just a checkbox activity. So you select on a database, I want patching to be done, we will take care. I want scaling to happen, I want a bigger instance, we will install that for you. I want it to have a highly available architecture, we will take care of that. So that is called my managed database, which is Amazon RDS. And through this managed RDS service, I could deploy different databases. I will talk about them, and that would give me a way to deliver my application the required performance and capacity without worrying about the back end stuff of high availability or operating system or patches. This one is referred as my managed database. All right. Any questions, any doubts, any confusion so far? Anyone who is not clear with managed databases? Let's now start focusing on Amazon RDS. So RDS gives you choice of different database engine. MySQL, Postgres, MariaDB, all my open source. MySQL, Oracle, enterprise grade, and Amazon's own engine, which is Amazon Aurora. So best would be I show this thing into console. So I could go ahead and maybe this is my AWS console. I am interested in RDS. RDS is a regional service. So I would select a region, and in that region, I would say I want to deploy a RDS database. There is a soft limit enforced on every AWS account. In a region, you can have up to 40 databases created. If you need more than that, ask AWS to increase your limit. But if you see here, you have 40 databases you could create up to. So I am interested to create a database. You have to select what engine you want for your database. So when I say I want to create a database, it would ask me some basic question. Let me go through a wizard, prepare some answer, and then let my database be created based on the configuration we have selected. So I could go with standard create, in which it will ask me some basic question. I am not interested to answer that many question, easy create. Let's keep standard and we will explore the options available. So I have 6 options to select from. 6 type of engine I could select for my RDS database, Amazon Aurora. Both option MySQL compatible and Postgres compatible. I may have MySQL, MariaDB, Postgres SQL, and Oracle, which I could use, or even I could have Microsoft SQL Server. So Aurora comes in 2 flavor. I'll talk about them, and then I have MySQL, Oracle, Postgres, and SQL Server to get started. Whatever you select, we will give you further options there. So you want to have a Microsoft SQL server, all right. We would give you option to select different editions of that SQL server, which version of SQL server you are actually looking for, any specific setting, like if you want to have any database instance created, then credentials configured on that, then instance size. Basically behind the scene, it is still a EC2 machine, but that would be managed and operated by AWS for you. So you could have selected different options available for your database which you want to deploy here. Right. You will provide some storage. We support auto scaling of storage, so your storage can grow as you want. We will start initially with 20 GB, but we will let it grow up to 1000 GB if you need to. And it is a kind of EC2 instance, so it would require network connectivity. I could have dual stack. I could run it as a compute resource connectivity also on that. Put it inside of VPC, go ahead with some additional setting about security groups, proxy services, and done. And I could also select some of the maintenance options here, right? Database port, which port I want to change. I want to have a SQL Server Windows authentication done. I want to collect data from it for monitoring. Maybe I want to perform a parameter, which is my customization done to it, type very specific time zone I want to use, when I would perform backup. Do I want to copy tags to the snapshot? So these are all the basic stuff. And see this, we could even say enable auto minor version upgrade. So AWS would take care of upgrade for me. I could select a maintenance window, and on that time my patches would be applied on my environment based on my requirements. So that is a good way to just have a database, and once I click on create, it would take care of the setting I specified, and my machine would be getting the database instance for me. Now, one thing to be aware here,
What you are creating a database instance. Let me draw that. So you are creating here a database instance. That database instance is basically made up of the server you need. This is a virtual server behind the scene given to you. And on that virtual server, obviously you have your operating system, and on that operating system, your database software is also installed. So once this instance is ready, I would use some tool which I am familiar with, like SQL Workbench or SQL Management Studio or Oracle's tool. And through that, I would connect to this database instance. And once this I connect to it, I would then create databases on top of it. So instance is the server of database, and on that instance, I could have multiple databases created. Shouldn't be a problem at all. And then I would be creating tables to store my data on. That's how your architecture would look like. I hope everyone is clear and following along that what we do when we say I am creating a database instance, I'm setting up the backend, and on that I would have my databases created. So it depends on, like, some engine would allow you to have a default database created, like Oracle would have something default, MySQL would have something default, and depending on the use case, you would be selecting what type of requirements you have, and your database would get ready for you. All right, very easy, not a complicated thing. So I hope everyone is following along. So we have choice of different database engine to choose from. We support high availability and read replica. I'll explain them in a minute, that what is my high availability and what is read replica. We will select all these things. We will talk about that. All right. All right. Now, what else? You could create snapshot which can be copied across region. So maybe if I want to have a backup of this database created somewhere, I could go ahead and put it into a snapshot. Snapshot, then I can go ahead and put it into a different location, different region, and restore my database from there. Should not be a problem at all. You can migrate database using DMS, a tool we provide by which you could move your on-prem databases or cloud databases to a managed service by AWS. No problem at all on that. And when it comes to pricing of Amazon RDS, the pricing is on demand, like how many time you keep launching that instance, you will pay for that. And if you have a consistent usage of a database, you would probably have a reserved instance created on that. So you would create a database and have reservation applied on that, so you would be able to get a cost on that. Data query only. As there is estimated cost mentioned, can we also create a serverless DB where it will be priced based on data query only? It can be done, Samuel, but that is only for Amazon Aurora serverless. So that will be Amazon Aurora serverless, where you will be paying by the node hours of Amazon Aurora. That is called Aurora capacity unit, which is made up of some compute and some scan capacity. So yes, that is possible. You could utilize Aurora's function, which is called Aurora serverless, but not possible with standard MySQL or Microsoft SQL or Oracle databases. They are not operating in a serverless fashion. So on those databases, you pay for the database instance. Right. So I deployed a database instance which has 4 CPU in that and has 16 GB of RAM. Even if I am using 1% of capacity, I am paying the same price. Even if I am using 90% of the capacity, I am almost paying the same price in terms of compute. So only Aurora supports serverless, not other services support serverless as of now. All right. Now, let me draw this. That will be easy for you to follow. Here we have a VPC, and now I'm just using some subnet here. Consider it is private subnet, and I could deploy my Amazon RDS. So what this RDS will do is will be creating an endpoint for me. Right. So it is going to be creating an endpoint for me. So this is my Amazon RDS endpoint, basically a connection string, a DNS name for my database server, and I would be connecting to that from my application. I would establish a ODBC or JDBC connection to talk to my database here. Once this is done, I could just keep it like that. But if I feel no, I need high availability, that time I would enable the multi-AZ feature on this. When I enable multi-AZ, what would happen? It would go ahead and create a copy of my database as a standby in some another availability zone. So it will pick up a subnet in different availability zone, like it is an availability zone 2, and will create a standby database instance. And then there would be data replication happening on that. This is a synchronous replication. What does it mean? Let's say you say write A, B, C, D. So ABCD will be written here. ABCD will be written here at the same time, and then only we will say yes, done, your data is available. So synchronous replication copies data in both the databases, primary and standby, and then only acknowledges. So that's what we are seeing here. Yes, we will be getting acknowledgement only of this. This standby database is just a standby. It is not serving active traffic, it is just waiting for failover. It is like a spare wheel in your car. No, you do not drive on five wheels, you drive on four wheels. The spare wheel is just sitting, and you would only use it if something fails. Same thing here. Standby will only become active when your primary database actually fails. So if it fails, automatically detection would happen. My service would detect that endpoint has failed, and then you would be having a standby picking it up automatically. You do not have to manually do anything on that. Yeah, it's kind of active passive. I agree on that. A question from Stockholm student: is database server and database instance same name? I would say yes. See, database server is a common word in on-prem world. In AWS world, we call it database instance, but actually it is a virtual server or a physical server which accept my database connection, which accept the request to connect, and then allows me to create a database. So instance and server, they are similar stuff, just the naming convention, nothing beyond it. Right now, what I could also do if I have a lot of read requests coming up, these databases RDS support something called a relay read replicas. So I could go ahead and create a read replica. A read replica can be hosted into the same region of my choice. Like here, I have a subnet 10.03 and I hosted a read replica one there. And if I need, even I could have hosted a read replica across region. So this is my region B, and then these read replica can be displayed there also. Should not be a problem, right? Read replica can be having data replicated by asynchronous fashion, which means it will be having little bit of delay before your data gets copied to RDS here. So read replica will be falling behind. They are not synchronous, they are asynchronous. So I write A, B, C, D. It may take A to come here, then will come B, then come C, and then come D. It may take little time for them, maybe few millisecond, maybe minute, but there would be little bit of lag between these primary and read replica. But the good point about read replica is that read replica get their endpoints. So I could just have my applications which require a lot of read, like my dashboarding application or my reporting application, and these application can go to read replica and read data from there. Shouldn't be a problem at all. You could decide to create it. And if I have a second read replica, it can also have a different read replica endpoint. Shouldn't be a problem at all. All right, I hope everyone is following along, and let me now ask some questions. My question: my primary DB instance is a, let's say it's a D dot extra large. Just give an example, just a random name. Let's say D2 dot extra large. Right. Now question is, can my standby of a different instance type? And can my read replica be of different type and size? So let's make it simple. This is, let's say, 4 CPU. So can I have standby with 2 CPU? Can I have read replica with 2 CPU? What do you think? Is it possible? Can we have this? Okay, let me now ask one by one. First question: can my standby be different size? Can my standby be different? That is true that you are saying that, okay, yes, they cannot be different. So they have to be same. Whatever is here, it is exact replica. So it would be requiring exact same thing. So that is true. Everyone is clear with that. No problem on that. Now, second question: can my primary and read replica of different size? Primary is of, let's say, 4 CPU and read replica is having 2 CPU. Can I do that? All right. Amrinder is saying no. How about others? Answer for that is yes. Right? So answer for this particular situation is yes. You do not need to have the exact same size for your read replica, but we recommended is that should keep same size, but not always. Maybe I'm just having a small report running from it. Why I would need that much of CPU? But if this replica here is having 16 CPU and this one has 2 CPU, then obviously it would increase the lag because they will not be able to cope up with the performance. So it will still be delivering you the result, but it would increase the lag. But technically, yes, it is possible. You could go ahead and create an architecture like this, should not be a problem at all. So I hope this thing is clear. So we could have different things. So that is good. We can use this commercial databases or open source databases. So then comes a request, why then AWS created Aurora? If this SQL databases exist, if Oracle was there, what is the need to create Aurora database? Let's talk about it. Commercial databases like Oracle MySQL Server, they would have feature, performance, and cost provided to you. They would be giving you a lot of feature. They would have a lot of cost also associated with them. So you may be paying a lot of money on that. Then we have open source databases, which is MySQL, MariaDB, PostgreSQL, which are having feature and performance not as compared to commercial, but the cost is low. So either I am compromising on the cost or I am compromising on the feature or performance. So that was obviously a gap there. Users have to select one or the other. So that's why Amazon has come up with Aurora database, which is feature and performance rich and on the lower cost of your application. So that is what Amazon Aurora is. I'll talk more on that. I have a question here from Babita. Can we replace standby with a read replica? No, no, you cannot replace a standby with a read replica. So standby, if it fails, another standby would be automatically created. It will be taken care by the system. Let me go back to the design we had. So let's say due to whatever reason, this AZ2 completely goes down, which means my standby will also go down. What AWS will do? AWS will find out another AZ3, and probably you would have a subnet there also. So it would start creating a standby there. So that can't be replaced by a read replica because they are a different way of working and they operate differently. So that won't happen. But in case, let's say, if region A itself goes down, your subnets are down, your VPC is down, and everything in region A is down. If I have this read replica, I could promote it. So that promotion is possible. You could promote it, but you have to do this manually. And your application is still talking to the read write endpoint. You may have to modify that so that it would start talking to your read only endpoint, which is now read write. So this promotion can happen and read replica can become primary, and then it will be able to serve traffic, but you would need to update your application because your application is not aware about existence of that particular endpoint. So just be aware about it. But yes, you could promote it. Good. So Aurora is there. We can use it, and Aurora has different flavors. Aurora comes with single master, multi-master. There is a global database. There is a serverless version V2 and V1, and you could utilize these things. So Amazon tried to address the problem of feature and performance on a lower cost, and then it is a database which is designed with cloud native mindset. So here, what Aurora is doing, Aurora is trying to create separate compute and separate storage. Traditional databases cannot scale that much because their compute and storage is packaged into one single unit. What Aurora is doing, Aurora is keeping storage layer separate. So all your log commits and all your data is kept separate. That is what refer as Aurora storage layer. And storage layer is basically a volume of clusters, and your data is stored across 6 copies in 3 availability zone. So we would have 6-way replication across 3 AZs. There would be a lot of copies of your data would be maintained on that. That would give you the piece of durability. That's how it will work. So it is compatible with MySQL and PostgreSQL. You could just come in and replace your MySQL and Postgres with Aurora, and it should work. Drop-in compatibility, as we call it. It stores 6-way replication across 3 AZs, and you have up to 15 read replica with replica lag under 10 milliseconds. So again, sometime in your questions in exam, they would be very specific about, I don't want my read replica to have lot of lag, what my options are. So maybe Aurora read replica would be a better option, and there is automatic monitoring and failover happening on that. It will be automatically done by the service itself. So I hope Aurora is clear. I'll talk a little bit more on Aurora, and then we will go to the hands-on options. Now, when you are creating a Aurora cluster, so we create a cluster, and in a cluster we would have a node. So if it is only one node, that node is both read and write copy, right? It will accept read, it will accept write. So what is going to happen here, that we would get two endpoint created, right? So what we will have two endpoint. There would be a cluster endpoint which will accept read write, and I would have a read only endpoint. Currently both of them are pointing to only one copy because only one node exists, right? So that is what my single node Aurora cluster would look like. Second, we have a Aurora cluster with two instances. So out of that, one will become read write, another will become read only, and now my cluster endpoint, which is accepting read write, will point to read write copy, and read only will point to this endpoint here. So that's how it will work, right? On the other hand, if I say I want to have multiple Aurora instances, so that is good. What you could do now, you could have read only instance 1, read only instance 2, read only instance 3, and you do not have to manually talk to each of them. You would still have one endpoint for read only, and it would perform load balancing for you. So you send a request that, hey, I want to have something done, and this endpoint will say, okay, let me get it done by node number 1. Second request, node number 2, you will work. So third request, node number 3, you will work. So this will perform load balancing automatically. So you as an application owner just talk to this, and it will identify who is the optimal way to deliver the data, and it will only forward request to all those node behind the scene. So this automatic load balancing is happening behind the scene. Now this confuses people. Let's say you run a SQL query and it requires access of, let's say, 6,000 records. It doesn't mean that you would have 2,000 served by this, 2,000 served by this, 2,000 served by this. No, we are not distributing your query. What we are distributing, let's say query number 1 comes and it requires 6,000 record, query 2 comes, it requires 100 record, query 3 comes, it requires 500 record. So we will forward queries to these nodes. They would still work on their own to serve 6,000, to serve 100, and to serve 500 data point which you have asked about. So that is how your auto scaling would be working. It is auto scaling of the request, not of the query. So just be aware about that factor. So read-only endpoint are scalable, and you can keep on adding more node here, and you don't have to change anything. You would still be having one read-only endpoint. And in cases, if you want, these also have their own endpoint, so you could directly talk to these databases. But most of the time, I would talk by a group endpoint rather than individual instance endpoint. So that is what a Amazon Aurora as a service is. All right, so I'll stop here. I hope everyone is clear. I will include the service summary card so you would have a better understanding, and I would also include it for Amazon Aurora serverless so you would have a better idea on how all these things work together. Thanks, Michelle, for answering the question. So yes, that's how we would be scaling. Auto scaling will be done by that. So you scale horizontally and vertically on RDS. However, the horizontal scaling is purely for read operation, and you can scale vertically for write instances. That is true. There is an option on Aurora Multimaster, both are active. So is this cause the endpoint common or distance? That would be different endpoint. So it would be sharing the load Parna in that case. So in that multi-master model, what would happen that there would be one endpoint for read write, but then it would do balancing for you behind the scene like it was a read only endpoint doing, and it will take care of failover also. Automatic failover will also happen in that multi-master fashion for you. So yes, both will be accepting through a common endpoint. They both would accept read write request, and then they would also do failover if there is a problem on that case. So that is what would be happening behind the scene. Multi-master is little more complicated than what I explained. So maybe when we get time, we will talk more on that, because again, there are a lot of logistics information, lot of limitations on multi-master, but yes, it is also a good option available. All right, good. Thank you, everyone. I hope you have enjoyed the 1 hour, 90 minutes or 95 minutes of your discussion. And now I would add Prasad to the link so that he can come and share his details here. And keep your questions coming. And Abhijit joined us for a while and then he had to drop off. But yeah, he is supporting us from backend, helping us. Michelle is also helping a lot with all the stuff. And obviously, Prasad is there. So let me now add Prasad to stream and he would then take over. Thank you, everyone. I will be here to answer any questions if you need me. Thanks.
Thank you, Ashish, for Another yet again analogies filled and insightful session. Yeah, I always learn more. Thank you so much. Let me share my screen. And hopefully, I see there were a lot of questions about, read replica, standby, and all. We'll see few of those in action. So hopefully, it'll probably, once we see in action and when you will do it yourself, hopefully, uh, things would be more clear. Let me share my screen and then add it to the stream. Cool. Okay. As usual, we start with the workshops. Here, if I just type RDS, now I know, Ashish did cover more than RDS, right? He was talking initially about SQL, no SQL. We'll start with RDS and then we will see if we have time. I would like to show you about few workshops about at least DynamoDB, because that was one of the, key value pair or document DB. It supports both in DynamoDB, and it's quite cool. So I'll at least point you to the workshop so that you can do it yourself if you're new to NoSQL database world. But we'll start with the RDS, and like as Ashish mentioned, RDS comes in multiple flavors, right? It comes in SQL Server, Oracle, PostgreSQL, Aurora. So we have a lot of, uh, for Aurora also, like we have a full immersion day for Aurora, PostgreSQL, and there are many other workshops that we have. For this
Prasad,
purpose,
can you make it a little more zoom in so that it
yes,
would be much
yes,
better visible? Thank
yes,
you.
yes. Let me do that. Is this better? Hopefully, it should be good. So we do have, RDS
Yeah, this is
for
better. Thank you.
PostgreSQL, cool. RDS for Oracle, RDS for SQL Server Workshop, multiple. Again, they go to different levels, level 200. So um, yeah, level 100 is the least technical, and level 400 is the for the experts. 200 and 300 would be more intermediate. So actually, I come from a SQL Server background. I want to show you this RDS for SQL Server, and I did, in my account I did create. But problem with this would be that it would be incurring you cost a lot. SQL Server is costly because of the Microsoft SQL Server licensing, unless you are using a SQL Server Express edition. So right, so we will create few, but I'm going to just show you here in this particular uh, in create DB instance. This particular workshop says that go ahead and create uh, the SQL Server Enterprise Edition. Please do not do that unless you are willing to pay from your pocket. It's costly. If you want to try SQL Server, try the Express Edition. That's the free version. But if it will not be having features like multi-AZ and stuff, just to play around and create an instance, and then if you have SQL Server Management Studio, anyone coming from SQL Server background, SQL Server Management Studio is a client through which you will be able to connect the database. You can do that, and that pretty much would be kind of what do you call free tier based on the instance size you will select, but never go for this in your personal account. And that is why I would be preferring doing Amazon RDS for PostgreSQL workshop. And other reason why I preferred to show this is because obviously we have limited time right now to do, and it is neatly, kind of uh, divided in multiple sections. The foundation, if anyone is getting started, intermediate, and the advanced. And then we have PostgreSQL for developers. Uh, so like in the foundation, we will create RDS instance, set up the client, we'll talk on the scalability, that how you can create a read replica, how you can promote a read replica and perform the vertical scaling. There was a question on, how can we scale? So, and Michelle answered it correctly. Like, you can scale either it, horizontally by adding read replicas, or vertically, the writer instance by adding more capacity to it. And then, Ashish's analogy about, we will see it in action, that can we have a different instance size for a read replica? Yes. Can we have a different instance size for multi-AZ? No. So all of this, you will, obviously will not be having time to cover all of this because creating them, it takes 10 minutes behind the scenes. I did create few instances beforehand, so I'm going to show that, but you can always try these, but be wary of the cost. Though it is PostgreSQL, but it doesn't mean that it will not be costing anything, it will be costing lesser than SQL Server, but yes, there will be some cost. So ensure that you have the budgets included, and yeah, and you're always trying it within free tier, or try with for 10-15 minutes and close it off. Cool. So let's start with this workshop. So in the prerequisites, obviously you can create a lab environment using the launch stack. I already created it, so we can go through this launch stack. So we have this, like a YAML file. We can go through the launch stack actually. So uh, console. So what I'm going to do, I'm going to go to CloudFormation. So this is the launch stack for this RDS PG labs that got created, and then it has a nested CloudFormation. I'm not sure if if you guys have still like started learning CloudFormation or not. So CloudFormation, in like you can have multiple stacks into it. You can create. It's more like a good level of what do you call it, segregating your code. You can have separate stacks, and you can refer those stacks here. So in this stack, it simply like it's going to have multiple other stacks. But if you go to the each of the stack, it talks about exactly what is created. So whenever you do these workshops, right, on your own, always try and understand that what is the basic environment that has been provided to you so that you can do the workshop. More often than not, it'll give you the basic networking, like tricks, basic, like IAMs and so on, so that you're operating within a secured environment. So try and look into that to understand, like if you want to create that environment on your own from scratch, will you be able to do that? Go through those YAML files and understand what exactly it is creating. uh, Initially, if you are not able to understand YAML files, look into it like these in the resources section. And when you're able to understand this, then go to the template section and go through the template code to understand that what exactly it is, what is it is exactly creating. And that will be really important. And like Ashish is covering almost everything here in the basics, like in the VPC, he does talk about like internet gateway, public subnet, private subnets, and so on and so forth. So see how that actually works in action. Like if you're creating a database instance, you would not like to create it in a public subnet. You would obviously create in a private subnet, right? So if you see here, there are 3 public subnets that was created, and there are 3 private subnets that were created. And when you will be initiating, you will be initiating it in a private subnet, a database. uh, Public subnet would be mainly for your bastion host or something through which you will be able to enter. So ensure that you are looking into all of this so that you understand that environment that has been provided to you, on which you are building on the lab. Cool. So that was the first thing. Now if I go back to, let me close the window so that we do not have too many things. This is SQL Server Workshop, not required. And yeah, this is the one. So we will use just these 2 tabs. This tab is our environment account in which we are working, and this particular is our instructions. So once you have launch, you will have this, and then in the verify lab environment, it says that you should be able to see the Cloud9 URL. So Cloud9 is a development environment through which you will be able to. Oh, I closed the development one. I did open it. So let me open it again. Open. So outputs, in the outputs you have Cloud9 URL. Through this you will be able to it. You can have a client environment through which you'll be able to connect the database. So I'm going to click and open it. So, and I I'm going to keep it here. When it'll open, then we can look into that. No. So it says that it's open. That should be open within few seconds. That should be fine. Now click on next. In the foundations, it talks about the basics that we'll be doing. And in this particular lab, we will be creating a DB instance, retrieving the DB instance endpoint, and creating a secret manager secret. Now I have done all of that, but we are going to see how we can do it. So let me go to RDS. I'll click on create database. We'll also talk about a few other things. Come on. It's taking okay, cool. Ashish did walk you through this, but we're going to look into it quickly for specific PostgreSQL for this particular lab that we are creating. And again, as Ashish said, we have two options: easy create and standard create. Go through standard create so that you should be knowing all the options that you have. So okay, I'm going to go for PostgreSQL, not for Aurora Postgres. So we are looking into RDS for PostgreSQL, not Aurora for PostgreSQL. Okay, so in the PostgreSQL, the engine version, you can look into whichever PostgreSQL specific version that you would like. The templates, yeah, I'm going to use the production, but you can always use the free tier. Few of the options in the lab would not be available in the free tier, but you can try to, like do that, but it should be fine. Now, in the availability and like durability, there are three options here. We did talk about single DB instance. We did talk about like multi AZDB instance. I'm not sure if Ashish covered a multi AZB DB cluster new. So this is a new option that is coming has come, which creates two readable instances standby, a primary and two readable standby instances. So that's pretty cool. You can always try it out. There should be more option on that. Let me show the documentation to it. So there'll be a writer instance and there'll be two reader instances that were created automatically. So that's cluster. So there's a difference: multi AZDB cluster and multi AZDB instance. Cool. Coming back here. So right now I'm going to go for single DB instance, and we can give the names and your credentials, whether you would like to auto generate it, create it in the secrets manager, uh, or you can give your own password. And the instance size, again, if it's production, then mostly it'll automatically suggest you for a provisioned IOPS SSD. You can always go for general purpose SSD. A GP3 is the newest version. And then yeah, storage auto scaling, you can auto scale the storage if required. And here in this dot connector EC2, so this is where like the infrastructure that is provided to you comes handy. Instead of using the default VPC, not the best security practice, you can always use this particular labs VPC that has been created so that your particular database is created within a secured VPC and can be accessible only from the required subnet and the security groups. It will automatically select the right subnet, and then the security group, you can select the security group that was created for this particular lab. Now, generally what I recommend is that always when you do this, go ahead, look into the security group, look at the settings that it has. Cool. RDS proxy, another like cool feature. It is a bit advanced, so I'm not going to go into it, but it can create a proxy so that you can like manage highly available database proxy. Like that's really a cool feature. And then there is something called custom RDS also, which gives you an option between uh, a database installed directly on EC2, that where you'll have access to the underlying to make any custom changes that you would like, versus a managed a database like RDS where you do not have access to the underlying. So custom RDS is where you have some options in between so that you can do it. That's and also get the management that gives the RD fully managed service. And then monitoring performance insight is really useful. There's another workshop altogether on performance insight, that how you can monitor the performance of your RDS databases and stuff. In the additional group, there should be only database option, your initial database name with what your initial PostgreSQL database name you would like to create, and then the backup retention period along with the encryption. Right. So this takes a lot of time to create. So what I'm going to do is that I already created, and I'm going to show that. So in the database instances, now created multiple databases, one for SQL Server Express Edition. It should not be costing you much. SQL Server Enterprise Edition, it'll cost me a lot, but that's fine. Then we have RDS, right? So Few things that I would like you to notice here. Multi-AZ. As of now, all of them that I've created is multi-AZ, no, apart from the Enterprise Edition, which by default creates the multi-AZ always on, right? And if you see Express Edition, it has NA. So with Express Edition, you'll not be able to test multi-AZ because it does not support that. But it's cool for your, like development practices, normal things. Now, let's go. So if you see here, this is the primary and this is the replica. So what I did, and I'm going to show that again to you. I created the main instance the way I showed right now. Then after that, I created two read replicas, this one and this one. And then I promoted one of the read replica to become a standalone instance. And that's why this became a standalone instance. So let's do that. So I'll first of all, I'll show the, instructions here. Okay, before that, yeah, I keep jumping ahead of myself. Retrieve the DB instance endpoint. So whenever you create a RDS or instance, you will need an endpoint URL to connect to it, right? So this is the endpoint URL through which you'll be able to connect to it. So copy paste and keep it with yourself. I've kept it on a notepad. In fact, so yeah, I have it. So you'll be able to connect to this endpoint. Now, depending upon what client you are using, you can use that. Uh, Now, coming back here, then it says create an AWS secret manager secret. So you can create your own secret for this particular RDS that you have created, right? So I've used the master user and password, and through which you'll be able to create your own secret, and then you'll be able to save that, store that secret within the secrets manager, right? So for that, let me do, and I already did that, but let me show that. So I've created this secret PostgreSQL master user. So I've created a secret specifically for this. So now it says that set up PostgreSQL database client so that you'll be able to connect to this and do some operations. So for configuring the workstation client, it's going to ask us to do it through via the Cloud9. And I've already done that, but let me show you how exactly it is being done. So once you connect to your Cloud9, which is through the URL here, it will ask you to go through a window and new terminal. And in the terminals, it has created one, a command, and run the command after DB endpoint is known. So once you know the DB endpoint, you'll be able to run this command. And at the end of it, once you run this command, it will be able to get you the URL and password, and it'll be able to connect to that. And once you connect to that, it'll save all the environment configuration variables here. Now, if you are using some other client like a DB viewer to connect to PostgreSQL, even that is fine. If you prefer a more UI specific, and that will be easy because you have a endpoint that you can directly connect to. Just give the endpoint, give the port, username, password. You given it on your own, and you'll be able to connect to it, right? But if you want to do it via Cloud9, once you do it, for example, I am in the CLI where I'm connected to the database, so I can run this query, select current user, current database. It's going to tell me that I'm the, and this database. So PG Lab was the initial database that I created. So you can always use this, so just to show that we are able to connect to database through this. Right, let me see if there are any questions in the chat window. Can you please move the video of the Prasad towards right? Oh, sorry. Okay. Yeah, we can remove the video also. Uh, what else? Okay, cool. I think we are good. Parna, thank you for answering that. Now, coming back here and verify the DB instance. So that's what we did. We verified the DB instance that we are able to connect to it, and we have quit. Now, going back to where I was jumping ahead to creating the read replica to provide read scalability. Something that Ashish has beautifully explained about the asynchronous replication for the read replica. It's not, like real time. It's not synchronous like you have for multi-AZ. It's a asynchronous read replica. But how to do that is, let's do it. Let's create another read replica. So I'll select the main instance, click on actions, and there's a create read replica. Now, when I create read replica, it is going to create a RDS read replica, right? There is, if you see this option, create Aurora read replica, you can always create a read replica which is a Aurora instance also. Now, why this option would be handy is that, let's say if you have a customer who has been running Postgres on-prem and they're moving on to AWS and they want a more managed thing, but they're, because they have been, like always using PostgreSQL, they are not very sure about Aurora. So they can always move as it is their RD, like Postgres to RDS Postgres. But for the read replicas and to just to try Aurora, they can use create Aurora read replica so that they get more comfortable before making the full switch to Aurora if they would like, right? But let's go ahead and create a read replica. So the replica source is which database do you would like. So we have these databases which you would like to create a read replica. Oh, come on, it's quite slow. You can give any identifier, read replica. Now, by default, it has shown me the instance that I used to create the main instance. But if you would like, there is an option to change it to whatever you would like, right? So it can be different. So let's say if you have a very read heavy, first, let's say you have a reporting service. Obviously, running the reporting service on your main database would not be great, right? So your writer instance, have it separate and have your reporting service, which is querying the data again and again to just to create the reports, have it separate. And that's, let's say, a very heavy reporting service and runs, like very frequently. And you might want to have a, like a more powerful read instance. Then this is where it can help, or vice versa. In case if your application is very write heavy and your read instance, you want to have it, but it like it's used once in a day or something to create some report or something like that, you can use a lower power um, you know instance. And then rest of the stuff, it's again, like you can choose what you would like about, like all of things. Now here again, you can use it as a multi-AZ DB instance or a single DB instance, and then cluster that we talked about. And then once you create it, I'm not going to do that right now, then you will be having a read replica created. Now if I go back, cancel this and go here, so this is the read replica that was created. You can see it directly from here, right? It will have its own what do you call, endpoint. So if I click on read replica here, it has its own endpoint. So your application needs to talk to this endpoint. Yeah. Now I have this endpoint, but for whatever reason, I would like to make this uh, the main, right? So let me go ahead and, sorry, show it here. Read replica, we created it. You can change, note that you can optionally size the read replica using a different instance tier than your primary instance. And then for the network security, obviously you would like to have the same destination group, so do all of that, and you'll be able to create that optionally if you are, like if you want to do all of that via CLIs, which is really good in case if you'd like. So this is the one. So all of those steps, it simply says that create the DB instance read replica, identifier, you provide the name, source identifier, you provide this, and then you provide the instance class, and rest all of this is different. If you want to change anything, you can simply add the tags for those also, and simply change those, add the options of those, and change those. Now, promoting replica into a standalone instance. Now, obviously, before that, you would like to see that there is no replica lag. As you said, it's asynchronous, so there might be replica. So whenever you're promoting your read replica to the uh, standalone instance, always sure that no, all the replica has been done. There is no specific lag there, so that the data loss is minimal or zero. Now, to promote it, you can just click here, actions, promote, or you can obviously create a Aurora read replica also. But yeah, promote, and once you do the promote, you would be able to have it as a separate. So I'll show you here. So to create that, you can always right click here and click on promote. So it's going to promote, and how it obviously it will go into the modify stage, and it'll it will take some time. I think it took almost 15 minutes, or I was getting impatient when it was doing it. I did not know the actual time, but it took quite some time. But then it made it a like this was under this like as a read replica, but this became an instance on its own. Now when it became an instance on its own, I can always add a read replica to this. So I'll have to so let's say you have a test database and you want to create another test database or something like that. So it's quite easy to like backup and restore is always there. You can always do a backup restore, but if you want to do it in this manner, this is also pretty much possible. Create a read replica and then make it standalone. Cool. Now going back here, perform vertical scaling. So this was about horizontal scaling, but let's say you realize that your main instance needs to be like of a higher capacity. Then simply go to modify instance and change the instance. It will take some time, but it is going to like do it. And you can always like schedule is or apply immediately. You can always like schedule it for the maintenance window, or you can apply it immediately and it's going to apply it. Again, we have CLIs. I love the CLIs because it's so handy. Again, it simply says that it was db t3 medium, and you're moving from medium to large. So you simply say now instance class is db t3 large, apply immediately, and boom, it's done. So just to show you here, modify, and then it'll give you all the options where you can simply go ahead and change it to whatever you would like. Keep rest of the things same and continue. Not going to do that, but that's how simple it is to vertically scale it. And horizontal scaling, we have read replicas. I know we are already over time. So yeah, in the foundational itself, there are multiple things that you can do. High availability, you can try your own multi-AG settings, right? And set up the high availability. Perform the failover. I love this. Like once you set up a multi-AZ and you're connecting to the multi-AZ endpoint, then you can perform a failover. What you can do is that you can take the main one and click on reboot and reboot with failover. So it's going to failover automatically to your, and then you in the logs, you'll be able to see. Let me expand this. The user requested a failover DB instance so that you are able to test the other one. Multi-AZ instance failover completed, DB instance restarted, multi-AZ failover started. So you can look into that. And then there are optional labs here. Now, you know, data recovery, backups, automated backups, modify backups, sharp shorts, try, like even if you're not trying them all because of the cost or like time, but try and go through all of this on the console. Obviously you can go through the instructions here, but at least on the console, open those tabs, look into those options, what are they, because then actually it helps you know and look into these CLI commands, like how it can be done. Now database upgrade. Now we know that the version of the database keeps changing. Like for example, we saw that, for example, DB engine version. There are so many DB engine versions, right? So if you want to upgrade your database engine to the latest version of whatever SQL Server, PostgreSQL, MySQL you are using, then you need to upgrade it. So what are the best practices to do that? How would you be doing that? So automatic minor upgrade, upgrading a engine version. So all of that would be here. So go through those. Monitoring the performance. Now this is where your performance insights, CloudWatch logs, alerts, everything, all of that comes into picture. And this is just the foundational part where you will be getting, like then we have intermediate, where you have talking about RDS proxy or migrating to a graviton encryption. And then we have advanced. Uh, so depending upon at what stage you are and what background you are, if you have been a database administrator, then obviously probably these things would, the foundation one would look like a good refresher, and then you would like to move on to the advanced one. But what I'll do is that I'm going to quickly show the
Prasad, I think we lost your audio.
is it?
Yeah, now it is
Hello, can you
coming
guys
up.
hear me? No.
Now I can hear you.
Oh, okay, cool. So the other RDS, like you have one specific RDS monitoring workshop where it talks about specifically performance insights, and that is really cool workshop. So, and depending upon whether you are coming from a PostgreSQL, Oracle, or SQL, go ahead and do those workshops. So in this RDS performance, so it's like through CloudWatch metrics to enhance monitoring, then the logs and the performance insights for RDS. So I would encourage everyone to like have a look at these. And like, again, if the question is about whether it is important for certification or not, because I saw someone asking about that. So probably, and someone probably said also that RDS is quite asked in the certification. Irrespective, these things are really important when you will be doing, or managing workloads on cloud, right? So the way we used to do the performance tunings for databases in on-prem versus the way we do in a cloud-native manner on AWS uh, is a bit different. So it is better that you learn about those things, and it comes really handy. And for DynamoDB, there is a workshop, Amazon DynamoDB workshops and labs. So this is also quite good. And but it might also become a bit advanced in case if you are new to NoSQL database. Uh, if you want to talk about generally all databases, then we have AWS purpose-built databases. Again, this shows level 400, but it takes you there gradually. So we're going to put all those resources in the resources sections, and then you will be able to look into these. But the lab 2 here is quite good. It shows how DynamoDB can be used with AWS Lambdas. Data can be pushed into Aurora. It's quite cool uh, workshop here. A bit advanced, but yeah, if you're up for it, try it out. That's all. I'll look if there are any questions on the chat. Nope. Cool. In that case, thank you so much. We will be sharing all of these resources, updating the resource sections in the BESA page
Yeah,
soon. And
we have updated these resources and we will put the link for the workshops so you would have access to it. Even if you do not want to do everything, at least check what options are available. As Prasad mentioned, like going through the information on like what options are there, what type of graphs are available, what metrics are available for me to monitor would help you to understand the aspect of it, and you can use those skills when your time comes. You do not have to know everything at top of your head, but at least know that these options exist, so when the time comes you would be able to utilize them at your own convenience. So that's what would be RDS. And the workshop you saw had different section, right? And I'm sure once you complete the whole, you would have a different perspective and a different confidence on AWS databases. So go through these workshops. I know cost can be a factor, so look for immersion days where we sometime run public free immersion days where you could go ahead and try out on a secure environment in a isolated shell into a sandbox environment, so you won't be having cost also on you. So that is a much better thing to try on. So look for immersion days. We would keep on informing you if we are delivering any immersion day. We would be happy to invite you there, and hopefully you would learn a lot on that. So let me also thank Michelle and Abhijit here. If you are on camera, Abhijit and Michelle, I would like to add you here so that we can see the faces who are helping us a lot on these things. So thanks, Abhijit. And we really appreciate you all taking time, and keep questions coming. Connect to us on LinkedIn, and we would be happy to answer as many questions you have. That's completely okay, Michelle. It's nice here too. All right, good. Anyone, any questions, any doubts, anything we could
Okay, well,
help you with, please let us know.
anyone who is in,
Yeah,
sorry.
WSS Pro. If not, what other resource we need to look? So we plan to talk about certification into a different aspect. So we hopefully will have a certification specific track. So don't worry on that. We will talk about certification separately. So thank you everyone, and have a good day. And we will talk to you
Hold on.
next week.
If
Check the
anyone
resources
is in
section.
London, if anyone is in London and wants a deep dive hands-on, then few of my colleagues are conducting this event. You
Yeah,
can simply
nice.
register with your yeah, company email address, and you should be able to attend it. It's an in-person event in London, a whole modernization workshop, bit advanced, but yeah, it'll be a good one. Mm. I'll not be
Yeah,
there,
means
but few of my colleagues are there and conducting it, and yeah, it'll be a good chance for you to even network with those folks.
thank you. Thanks for sharing that. And thank you, everyone, Michelle, Abhijit, Prasad, and everyone who joined. And we will talk to you next week. Have a good one.
Thank
Cheers,
you.
thank you
Bye
all.
bye.
Cheers, bye.